Let's try that again. There we go. Looks like we're live now. Welcome everyone to the Unity 2021 TechStream webinar. We're very excited for you to be joining us today. We'll give just a minute or so here to let everyone trickle in. We just opened this up. Lots of people are still joining us today. But we'd love to know where you're joining us from. I'm coming to you from London, Ontario, Canada. I know our panelists are coming from literally around the globe today. The chat feature is open. Feel free to go in there and let us know where you're coming from. See India coming in strong right away, Montreal, France. Last time we did one of these, a lot of Europe. I guess it's still pretty early morning for the Americas, but Europe's alive and well. We will get started in just a minute here. Our numbers are still going up, and we will begin. I miss those days where we used to start an in-person webinar and you did the like, how's everyone doing? And then they wouldn't say loud enough and you had to hype them up again. We need an online version of that.
What do you mean an in-person webinar?
I guess not in-person webinar, yeah. COVID's getting to me. Everything now on GDC is just an in-person webinar. That's what we're going to call it next year. All right, let's see.
A personar.
A personar, that's what we'll go
yes.
for. Everything's changed. All right, let's get started here. Let me share my screen. All right, so as everyone trickles in, welcome. I'm glad you could be joining us today for the Unity 2021 TechStream webinar. My name is Ben McElmoyle. I work as a developer advocate here at Unity, which means I get to spend a lot of time with creators and developers like you, kind of informing you on some of the latest and greatest features, as well as listening to your feedback that helps us shape what Unity becomes in the future iterations. So over the next hour or so, we're going to be diving into some of the biggest features from the latest TechStream release, talking about what it is and a bunch of cool stuff like that. But today, it is not just me. I have with me Bronson, Ashley, and Andy, who are all going to be presenting, as well as a whole slew of people from the research and development and developers that actually get to work on these features, bring them to life for you. They're all sitting by and ready to help answer your questions. That said, we actually do have one way to ask questions, but two ways to get in contact with us. So through Zoom, you have the chat feature that I see many of you are using now. If you just want to add comments or chat with the other community members, feel free to use that. If you do have a technical question or a question you want either one of us presenters to see or the background team here, please use that Q&A feature of Zoom. That'll make sure we see it. We are expecting quite a few people today. Quite a few questions normally come through. It may take us a few minutes to get to it, but we'll do our best to answer everyone if we can. So again, please use the Q&A feature of Zoom if you do have a question you want to ask us more directly. But let's get into today's topics, the Unity 2021 TechStream. But before we do that, I guess we need to actually kind of talk about the two latest versions we have. So if you follow Unity news, you probably saw a few weeks ago, we released both Unity 2020 LTS or long-term support alongside or shortly after the Unity 2021 TechStream. So we're going to be talking about the TechStream after this, but it is important to kind of realize why we have two active releases at one time and why you may choose one or the other. So let's start with the TechStream, so we're going to be talking about today. The TechStream release that just came out is where you go for all the bleeding edge features, everything that's currently happening, all the features we plan to add to Unity, anything that's on the roadmap right now, that all gets brought in through the TechStream. So by using the TechStream version 2021, you can explore the new capabilities that we have in Unity. You can pressure test components as we continue to build them. You get to really live on the bleeding edge and see all the new stuff that's coming down the pipeline. So for us this year, this includes features like visual scripting, the high definition and universal render pipelines, and of course the netcode. Got stuff coming for that as well. We've been talking about it for a while. I'm excited to get our hands on that. It's a highly requested feature. On the other hand, the Unity 2020 long-term support version. So you've probably seen LTS if you've used Unity Hub or something like that. That does stand for long-term support. And we just released one of those as well, Unity 2020 LTS. So this is the choice for stability and for matured features. So if you have a project that is going into production or maybe a game that's already in production and you really value stability, you don't need necessarily the latest features, your game's already pretty mature, LTS is a good choice for you. So the LTS, really, we will continue it to support it into the future for 2 years. We don't add new features. You won't get that bleeding edge tech like you would with the TechStream. It really comes down to where you are in production cycles and what you're trying to do with Unity at any time you're using it. So a few things to compare and contrast here. The Unity 2020 LTS or any LTS we release in the future, we have one major release of that per year, which for us just happened a few weeks ago. The text stream, on the other hand, gets two major releases a year, typically published in Q1, which just happened for us, and then you'll get Unity 2021.2 sometime around Q4. So a good few months in between. Technically, there is also a 0.3 that will come out, but when that happens, that's when we go to the next year, and the current year's text stream becomes next year's LTS, if that makes sense. So obviously last year being 2020, now we have 2020 LTS, and that cycle will continue going forward. The LTS will continue to receive support for 2 years, so I won't be adding any big new features or any APIs or anything like that, but if bugs do come up, anything like that, we will solve them for 2 years. So you know how you have a nice stable work surface to start with. The text stream, on the other hand, of course, we'll be doing bug fixes and adding stability to that, but we're also adding all the latest bleeding edge tech there as we go. For the LTS, you'll get bi-weekly fixes to the engine. For the text stream, they come in every week. So although there's only 2 major releases, every week you're getting updates for all kinds of different features, stability, all kinds of great stuff. So like we mentioned before, text stream is a space to go to get all the latest and greatest. So that last one, I just mentioned it, but the LTS, it will not get any new features. So if a big new exciting feature comes from a console developer or something like that, you'd expect that to show up in the text stream and not the LTS. Again, we're only there providing support for stability and regression bugs, anything like that. The text stream is where you'll go to find all those latest and greatest features. So why would you choose either one? Again, it really comes down to what you're trying to make with Unity and what's part of the life cycle you're in. If you're just prototyping something or you're starting up an active project that's probably going to take a year or two anyways, you may want to go with the text stream, get all the latest, greatest features, start experimenting with them, see if they can make your life easier. On the other hand, if you're just about to release a game, you probably want a lot of stability. Maybe you choose that LTS version. But enough about the two versions. Let's get into actually some of the features that we have in the latest 2021 release. The first thing I want to talk about today is updates to the package manager. Now, the package manager isn't new to Unity 2021. It's been around for a few iterations, but we have a few things that have been updated to make your life easier. If you're coming from an older version of Unity, maybe you haven't upgraded in a few years, the package manager is one single location that you can go to get all the different kinds of packages, and add things from the asset store. All those things come together in one place that I'll show you in just a minute. For me, I kind of like to think about this as like my fridge in my kitchen. I know my wife just went and got groceries yesterday. There's lots of good food in there. And if I just went out and just ate everything all in one go, I'm definitely going to be bloated. I'm definitely not going to be able to run fast after. And your games and applications are just like that as well. If you brought everything that the Unity editor has in store and just put it in your project in one go, it's going to be bloated. It's going to slow down your compilation. It's going to slow down the editor, and it's going to slow down your runtimes at the end of the day as well. So instead of just going and eating everything in the fridge at once, you can actually go in there, choose what you want as you need it, and avoid unnecessarily bloat, keep things running fast. Everything will be good. The biggest changes we see to that with Unity 2021 is the actual package availability lifecycle. We now have 3 official stages that a package can be in: experimental, pre-release, or release. Let's start with the experimental. So as the name entails, experimental packages are brand new tech that are still actively being worked on. They're in the early stages of development, and they are experimental. At this stage, they're not stable, and in fact, you won't actually find them in the package manager itself. These are features that you may hear about on like the Unity forums, or if you pay attention to the beta releases. These are things, again, very early on in development, and you actually have to manually install them if you want these things. They are unsupported by us. So even if it's a Unity initiative, again, it's experimental. That's the nature of it. Sometimes these features work, we bring them in further. Sometimes they don't, we go back to the drawing board. So anything that is in this experimental phase is definitely, like use it sparingly. Don't put it in a production cycle. Things will change, stability will get better, but it's early on at that point. After that, if it does continue to get worked on, it goes into the pre-release cycle. And these you can find in the package manager. We'll see that in just a second. Anything here is not officially in release yet. It's still being worked on. It's still being stabilized, but it is part of the roadmap, and it is officially supported by Unity. So anything here is really tech that we're working on, just like the tech stream, that we plan to bring bigger features, but need a little bit more time to bake and get feedback from community before it becomes a full-blown release, which is our final stage. So as you open the package manager for the first time, any package that you see there will already be in release mode. That means it's good to go. It's officially supported. It's been stabilized. We've got community feedback. We've gone through all the hoops, and we're good to go about this. So let's actually see the package manager in action here. I have a Unity 2021 project, just made it this morning. It's empty, haven't added anything to it yet. And to get access to my package manager, I'll go to my window, come down to package manager, and this is it right here. So as you can see, all of these different packages I have right now, I can click on any of them. As I go through them, you'll see they all have the green release badge with them. So all of these packages are in the release state, means they're good to go, they're ready for production. And if we scroll down here a little bit, you'll see some of them have check marks in them as well. And that's some of these features have changed with Unity 2021. Something like we have visual scripting in here is now included by default. So if you see those green check marks, that means this package is already included in your project. Like I said, the experimental packages you can't actually bring in this way, but you can do pre-release. So to get access to those, I go into Edit, go to my project settings, come to the package manager, and under advanced settings, we have the ability to enable pre-released packages. If I enable that, I've actually done this once, so I won't get it, but normally you get like a little warning and just a reminder to say, hey, these things are still being worked on. They're not quite production ready yet. So if you are going to use that, keep that in mind, but you can just hit OK. And now when I come back to my package manager, if you see anything with the little yellow pre, or it says pre-release up here, you'll know that package is being worked on. It is supported, but we're not in the full release state yet. So lots of cool packages you can use here, including things like the universal render pipeline, which isn't included by default. But I know, Bronson, you've got something to show us about that. Are you ready to go, Bronson?
Yep, I'm ready.
All right, let's see what you got.
Let me share my screen. Cool. Hi, everyone. So I'm going to talk about the changes to URP in 2021. And the one biggest change that I want to talk about first is they finally added shadows to your point lights. Yeah. So let me just pop open the Light Explorer here and see if I can find this light. Boop. Here we go. So actually, yeah, I'm going to turn off the directional light. And then you can see that there's shadows. Whoa. How great is that? So let's see. Okay, so let's talk about the point light shadows. So in URP 2021, point lights have shadows. And on every point light, you can actually set the resolution of the you know what? I'm going to open up another scene that's a little bit more obvious, but basically the resolution that it's using to render that point light. Oh no, where did I put my other scene? Here we go. Sure. Just a second.
I wanted to mention, Bronson, this is this scene that you're using to demo is an old glory, the Viking village, right?
Yeah.
Which has been updated to URP and is available on the asset store. So if you wanna playground for URP, that's a good demo to get.
Yeah, that's a good point, actually. Okay, so here we can see a little bit clearer. So for the real-time shadows with point lights, we have the resolution of the shadow here. And by default, there's kind of a low, medium, or high option. And you can see, hopefully you can, this comes through on the video, you can see the difference. There's no difference. Haha, I've caught myself. There's a trick here that I didn't mean to do on purpose, but I'm glad I did. Where, let's see now. If the shadow, okay, so here's the other option. This is why I didn't mean to do it first, but it's okay. So in the URP asset, under the additional lights section, we actually have all the option for the shadows for the additional lights. So that's everything that's not your main light, which your main light's probably going to be the big brightest directional light in your scene. That's going to be your sun, something like that. Additional lights is all the other lights. So point lights, spotlights, things like that. So right here in the additional lights section, we have the resolution of the shadow atlas for the additional lights. And if it's too small, you actually see there's a whole bunch of errors that I was ignoring that are complaining that it's too small to actually fit the light shadow into the shadow atlas. So if I crank that up, now you see some definition is coming through, and I can change the resolution of the shadow here. And for fun, let's actually open up the frame debugger. I'd have to place my camera though, I think. Let's go line with view. Frame debugger over here, enable that. And let's actually take a look at the shadow map. As you can see right here, this image that's being drawn right here is actually the shadow map for all our additional lights. Right now, there's just one light. And you can see it kind of change as we change that, and maybe even see, oh, when you make it higher resolution, it actually makes this image bigger. So that's a really useful way to debug those lights. And if I make a second light, now they're fighting for space on the same shadow map. So yeah, so the important things to note, let me just recap, is that you have to make sure, you have to check the resolution on the point lights, and you can set a different resolution per point light. And that's great if you have certain lights that are, let's say, of much higher importance than other ones when it comes to casting shadows. And then you also have to worry about the settings, the additional light settings in the URP asset. So that includes things like the shadow atlas resolution here. Here you can set the sort of defaults that apply to these. So 256, 512, 1024. You can say don't cast shadows at all if you wanted to. And there's also the per object light limit, which, you know, once we go past a certain amount of lights, you'll notice that the ground is not being lit by these extra lights right now, unless I kind of crank that light limit up, boop, boop, and those will pop in. So yeah, that's kind of the breakdown of the point lights. Let's go back to our Viking village. Okay, so the next thing I wanted to talk about, actually, unless Chiro, do you have any questions about the point light shadows?
No.
No? Okay, perfect. So the next thing I wanted to talk about is they've moved the Srp packages, so that's the URP and the HDRP packages, into core now, as opposed to whatever you would call when it wasn't in core. I actually don't know. But what this means is basically the version of the package that you're going to get is going to come with your Unity version. So when you download a new version of Unity, it has the pre-installed version of the Srp packages, so URP and HDRP. And that's great because now you don't have to worry about constantly, you know, upgrading the packages and making sure that they're the right versions. And then you upgrade one and then it has to upgrade the shader graph and blah, blah, blah. It comes with the version that you need for that version of Unity. So you can see right here that it is still available in the package manager under, I believe, not built in. Is it not built in? Ugh.
Built in is the modules, let's say.
Sure, but
right?
I think I'm pretty sure if it wasn't installed, it shows up in under built in. Am I not wrong about that?
No, I think built in is the modules, the ones that are not packages, basically.
Okay. Well, anyway, the important thing though for me, if you're anything like me, you probably actually you may use the source code of these packages to help you out. So I end up writing a lot of shaders, and in order to do that, especially shaders that I want to work with URP or HDRP, I spend a lot of time actually going through the URP and HDRP code. So the first thing that I was worried about when I saw that it was added to core was, oh no, do I lose access to this code? But no, you can see right here, actually, if I open up Writer, that these modules that are part of core are still available inside of the solution. For me right now, they're under this modules section. So URP used to be available in the packages. Now it's available under modules. And if I go in here, you can actually take a look and kind of go through all the different URP code. So for example, like, oh, if you were ever curious, like, oh, how does the URP's version of PBR work? It's like right there under, you know, lighting.hlsl, boom. Or, you know, if you ever wanted to know, let me find some good ones, how SSAO works, there's the whole file dedicated to all the different SSAO functions that go through and make the SSAO work, basically. So this is a really super good resource if you're ever writing shaders or doing graphics programming or anything like that. You can actually open up any packages, but still these ones in your IDE and read through the code and use that code. And you can call those functions, like for example, the universal, whatever it was called, any of these, the lighting Lambert function, for example, you can call that function from your own shaders because it's all included in the rendering pipeline.
And you can do that from shader graph as well, right? With the custom function node.
Right,
you can
exactly,
include bits of HLSL.
So this is something I've done personally that's very useful, is when you write a custom function node, you can go find, for example, functions that maybe there isn't a node for, but do exist within URP, and quickly write your own custom function to do that. There's an older blog post, I think, that shows how they did that to get the main light. Sure, I think did you write that one, or you were?
No, I was from Alex Lindman.
That was it. Yeah,
I remember that one.
So things like that are really, really useful if you're ever like, how do I access the main light or the additional lights? Or what if I want to write my own version of, you know, PBR or something like that? That's all available in there. Great. So the last thing I wanted to touch on is a little bit of future news. In 2022, they're going to be adding deferred rendering to URP. And that's exciting. I want to talk a little bit about like what's the difference between forward and deferred rendering. Maybe you've used deferred already. It was part of the built-in rendering pipeline. It still is, but now it's going to be in URP. So basically, in wish I had an example. So in forward rendering, how it works is the renderer itself will go through every single light in your scene and essentially do all the lighting calculations one light at a time. Or I think in URP, it batches it by like 8 lights at a time or something along those lines. And what that means is the more lights you add to your scene, the performance gets worse and worse over time, because every single light adds a bunch of extra new calculations that it has to do. The way that deferred rendering works is basically it does one pass before doing anything else, where it collects up all the lighting information into the G buffer, as they call it, which is, it's a texture, it's a picture, let's say, an image. And then they take all that lighting information, put it in one place, and then use that image to do all the calculations afterwards while rendering everything. So the drawback, I guess, is if you do have a very small amount of lights, it is faster to use just regular forward rendering because it doesn't have to do all this extra calculation, let's say. But if you're using lots and lots of lights, there's kind of an inflection point where all of a sudden it becomes a lot cheaper to go through that extra, first step of creating the gbuffer, and then use that to calculate all of the rendering information afterwards. There's a few other little drawbacks and trade-offs. Like, for example, transparent objects are a little bit more tricky to do in deferred rendering. If I'm not mistaken, last time I checked, in Unity, what it does is it kind of does the transparent objects as a separate pass using a sort of deferred-like approach, a forward rendering-like approach. And MSAA is not available in deferred rendering, I'm fairly certain, unless something has changed, because of the way that things are calculated. But anyway, that's kind of a rough breakdown. The sort of like the easy answer, if you're trying to decide which one to go with, is, am I going to have a lot of lights? Maybe I have kind of like an indoor environment, like some kind of dungeon or something that doesn't rely on like one big sunlight, but like lots of little torches and things like that. Something like deferred rendering might work well for you in that case. If it's more like a big outdoor environment, you probably have a sun, maybe you have a couple lights here and there, but not that big of a deal. Then you might want to go with something more like forward rendering. And I think that's all I have, unless I'm forgetting anything. Chiro?
No, I wanted to bring one of the questions to the stage, let's say, even though we answered already. Somebody was asking if URP 11 will only be available for 2021 and above. And the answer is yes, URP 11 is only for 2021. But if you think about it, if you reconnect to what Ben talked about for the LTS and the text stream, right? The point there is that because URP 11 is for 2021 and it's new features, we don't backport those new features to LTS, right? LTS is only for stability. So when we backport things, it's only going to be fixes and critical bug fixes. So for example, point light shadows, they won't be backported to 2020 LTS. And I think it's important to understand to make your decision on which version to use. That's the only thing I wanted to add.
Cool. Okay, so if that's it, then I'm going to throw it over to Ashley for visual scripting.
All right, and thank you. Give me a second to share my screen and we'll get started. Okay. All right, so hello, everybody. Hi, I'm Ashley, and I'm here to talk to you about one of my favorite features of Unity 2021.1, and that's Unity Visual Scripting. So if this is your first time hearing about the feature, know that it's essentially a way that you can create powerful interactive behaviors for your games or applications using drag and drop nodes within graphs instead of traditional C# code. So, and this is really useful because it can give visual thinkers and non-coder creatives a more accessible way to create interactions for their projects. Now, visual scripting supports every class and struct type in Unity, and it includes APIs for advanced tasks, custom nodes, and more. And really, this makes it a highly versatile tool to use in many different types of scenarios when you're working on your projects. So to kind of explain a bit more, like I want to jump into the editor and just show you how it works, but I want to give you some context of how you can use it in your projects, how we see it's most frequently used by teams today. And the first is that visual scripting is an excellent feature to use for rapid implementation of your interactive systems, art, animations, and more. Let's say you're a game designer and you want to test out a game mechanic, or you're an animator and you want to test a new animation that you worked on within your Unity scene. Instead of having to look up and figure out the C# code to check what you want to check, or alternatively ask a programmer on your team to implement this for you and then spend time waiting for them to do that, you can use visual scripting to throw a couple of different nodes together to quickly test out, let's say, that game mechanic idea you had or that animation you wanted to add. This also means that the feature is really useful for events like hackathons and game jams, where you need to rapidly prototype and test different interactions. And with that, I also want to mention that visual scripting becomes even more powerful when you use it combined with C#. So when you're working in a Unity project, you don't have to just stick with C# or just with visual scripting. You can use both together in really interesting ways. It enables non-coders to use existing C# scripts in their projects as, for example, nodes in their visual graphs. So let's say, what we'll commonly see is that there's a team of, game developers, there's some designers and artists and programmers, and the programmers might be making some C# scripts for backend systems and such, and the game designers may be using visual scripting to create out the game logic. But there are times where you want to reference those backend systems that the programmers are making. The game designers can actually just take those scripts and grab, let's say, a specific method they're interested in, use that as a node in visual scripting, and then add more logic to that to kind of extend what that script does or to reference what that script does. Alternatively, you're a programmer and you're working with your team and they need a very specific node for visual scripting. If it doesn't exist already, you can create it yourself using C# as well. Another way that we're seeing the tool being used is to create templates and resources to share with other people in the Unity community, whether that's somebody who's making a 2D platformer game template and sharing that on the asset store using visual scripting, or someone sharing some custom developer tools and nodes over on their GitHub. This is another kind of common use case we're seeing pop up with the community, which has been really wonderful. And lastly, visual scripting can be used in productions for versions Unity 2018 and above. But why am I mentioning 2018? Because we're talking about 2021.1. The very special update about visual scripting for 2021.1 is that it's now built into the Unity editor. That means if you want to get started with visual scripting, all you need to do is just open the editor. That package is already installed for you, and you can just start adding the components that you need to start your visual scripts. Alternatively, if you're using older versions of Unity 2018 to 2020, you can get visual scripting. It's currently listed as Bolt over on the Unity Asset Store. But the version of visual scripting that I'll be showing you today is the built-in version. It has an updated UX. We've changed the windows and the workflow slightly. And so you'll be seeing that nice new shiny version today. And so with that, I'm just going to go ahead and jump in the editor to show you how it works. So let me tab over to that. So here in my project here, this is a demo that we recently showed at the virtual GDC event that happened last month. And in it, I have this terraformer character. She's in this room. And essentially what happens is that when I press different keys on my keyboard, she will do different actions or animations. So in order to get started with visual scripting, all you need to do is add a script machine or a state machine to your game object of choice. Now I have our terraformer character selected. If I go to add component and I type in state for state machine or script for script machine, I add those components. And here's an example of a script machine one right over here. This is the kind of core foundation of where you're going to host your visual scripting graph for that object. So when you add a script machine component, it'll show you an option to create a brand new graph asset, which is saved in your project folder. Alternatively, you can use an embed graph, which embeds it directly into your script machine or state machine component. The main difference is that for when you're working with a graph asset, because it's saved in your project folder, as you make changes to it, it gets saved automatically. If you're using a embed source, then you can make scene references to other objects in your scene, but then you don't get you aren't able to, let's say like update it while it's in play mode and things like that. So, and also the core difference between a script machine and a state machine is that a script machine is generally used for a linear series of events, where a state machine is used to alternate between different sets of behaviors, depending on different settings or modes or, that your game object may have. A very common example of this is when you have an enemy character in your game, you might have it have a patrol state, an alert state for when it sees the player, a chase state for following the player, and an attack state. Those are different states that can be managed and jumped between when you're using a state machine. In this example here, I'm going to show you just a quick little example of how you can make something in a script machine. And what we're going to do is we have this player controls graph, this player controls script machine. I'm going to press edit graph to make sure that my script graph window is open. And we're going to add a couple of nodes, or what we formally call as units, to create an interaction for her to toggle her combat animation when I press the Q key on my keyboard. With that, this is the script graph window, and this is where you'll be doing kind of like all your work with visual scripting. And there's two sub windows here that you need to be aware of when working with this feature. The first is the graph inspector. The graph inspector is what tells you all the information that you need to know about the graph that you're working with or the specific nodes that you're working with. So let's say you're working on the project and you add a unit and you're not sure what it does or what it requires. You can click on it to see a description of that node, any settings that may be applied to it, and what I find really useful, what it requires for an input and what it outputs in return. So for this playable director unit, I need to have a flow. So a flow are these green arrows that you see on the units. These are what you connect together to establish the chain of events, so to speak, that happen with visual scripting. It needs a playable director target, which is already on the player, and it needs a playable asset. So it needs essentially just a Unity timeline to be able to play, because this is for playing a cinematic. So by clicking on that node and using the graph inspector window, I can learn more about that, what that node needs, and be able to make sure that I add that to my graph. Second is the Blackboard. If you use other graph-based Unity tools like Visual Effect Graph or Shader Graph, then you're already familiar with the Blackboard. Blackboard is where you keep all the different variables that you work with for your visual scripting projects. There are variables that apply just to the graph that you're working with graph variables. You can have variables apply to a specific object. So any graph on that object can reference it. You can have scene variables that any object in your scene can reference, and then application-wide variables and variables that can be saved and reference even when you close the project and open it again later. So with that, let me show you quickly how to create a basic interaction with visual scripting. So I'm going to scroll to this blank part of my player controls graph here, and I'm going to right-click to open up the Fuzzy Finder menu. The Fuzzy Finder is this really helpful contextual menu that lets you see all the different units that you can use in visual scripting, whether you want to work with time or math, or you want to use a control unit to do if statements or for loop. You can find everything you need here. And in this case, I'm going to type, let's see, input, because you could search also for what you want to work with, input system, on input system event button. So in this project, I'm using the Unity input system. I have the player input component with my actions attached to the player character already. So here it's asking, okay, on input system event button, when I press an input system event button, it's going to reference the player input component that's on self, that is on this game object. And then it needs to know what button are we pressing. So currently my Q key on my keyboard is binded to the mode change action. So when I press the mode change button, whether that's on my gamepad or my keyboard, I want a toggle of the animation to happen. So that when we'll go into play mode, you'll see that the character has a generic idle animation. And we're going to toggle over to, she'll have this enter idle, and then we want to toggle over to her combat idle animation. The thing that switches the transitions between these animations is the value of the combat mode Boolean being set to true or false. So we're going to change that in visual scripting whenever we press this key. I'll add a toggle flow unit. I'm going to make sure it starts off, so it's not on when we start our game. I'm going to connect the flow of the units here, like the series of events, to the toggle. So when I press this button, toggle the values of this toggle flow. When it's turned on, I want to set the animator Boolean, or animator set Boolean, set bool, and I'm going to tell it what the name of the variable is that I want to change, the Boolean. So that's combat mode, like we saw in the animator. And when it's turned on, we want this value to be true. And I'm going to Control-C, Control-V, copy paste my unit. And when it's turned off, we want this Boolean to be turned off. And to be determined with these value options here. That's it. So now I'm going to go into play mode and we're going to see how this works. And keep an eye carefully on the graph because you're going to notice something while I'm toggling these changes. And I want to make sure you catch that. So now we're in game view and I'm going to go ahead and press my mode change key. And we see now she transitions into her combat mode animation. But like zooming into my graph here, I'm going to change back. Notice, do you see like those little dots that flow between the arrows? That's because when you're using visual scripting in play mode, you can actually see the flow and chain of events happen in real time as you're testing your game. And this is super useful for understanding how your visual scripts work. In this case, it's a very simple example. You know, we just see it passing through these, you know, couple of units. But when you have a bigger visual scripting graph, it's so useful to see where the flow of your events is going, what is, you know, what's changing, how long it's taking. You know, sometimes you'll have like different sets of behaviors and you'll see the flow go to one of them and you're like, I'm not trying to do that. I'm trying to get to this other flow. So it's really helpful to visually understand what exactly is happening in your project. So with that, I'm also going to show you one more quick example of how you can use visual scripting, this time with C#. So back on my Terraformer hero, I have this other weapons graph here. So I'm going to click edit graph to open that one. And here I have a graph that's mostly completed to handle firing a bullet when she's in combat mode and we want to fire her gun. And so essentially what I'm saying here in the graph is, okay, when the fire event is triggered and the character's and Boolean is in combat mode is true, play a visual effect on the gun for the muzzle flash. And then we want to get a projectile from our object pool, do a null check against it, play the character's, you know, shooting animation. And then we're going to get that projectile that we grabbed from the object pool and set its position and rotation based on a spawn point that we have in our scene, and then set it to be active so we can actually see it. So right now, if I go to the game and I go into combat mode and I press space, we see the muzzle flash, but there's no bullet flying out. Now, this is an example of like, let's say when you're working with a programmer, when you're a game designer, you just kind of maybe care like, I just want to have a projectile to fire. The programmer, meanwhile, created this object pool behavior script that I have here attached to the player character. And in this object pool script, it also has methods, for example, grabbing a projectile from the list of projectiles that it created in our scene. So to use it, even though it's a C# script that someone on my team created themselves, I could just click and drag it into the script graph window. And now I can see it like its own little menu for it with the visual scripting fuzzy finder. And I can go over to the get pulled object option here. And now I can use that get pulled object method as its own unit. So I can just connect these two together. And what I need to do here is also show how I can connect these. So in the, oh, sorry, my Zoom freezed for a second. Hopefully I'm still live. The method here, what it does is that it outputs a game object, a projectile that I can use. And so even though I'm connecting the flow of this scripts method together with this visual scripting graph, I'm just saying we're with this connection, we're just saying, okay, get the pulled object, but we actually need to do something with that game object that we're getting. So I'm going to connect it to this comparison unit so that we can do a null check. And then I'm also going to connect it to this set variable unit, so I can save the current projectile that it grabs as the current bullet in the scene, so that I can apply any additional behaviors to it. And notice that I'm making all of these changes while we're in play mode. So this is also a great way to be able to change your logic on the fly and test quickly and iterate quickly when you're working with visual scripting. So going back to game view, if I press a spacebar and fire, we can now see that there's bullets appearing here in the scene. And so just with this simple graph, we can have that cool shooting animation happen. So with that, that's it for what I'm presenting here. And I'm just going to leave you with a couple of helpful resources. So if this was a very quick overview of visual scripting, I'm sure many of you have lots of questions to ask about it. And I wanted to share these resources here. So there's a general information page where you can find out more about visual scripting. There's a link to the documentation. We have a brand new section of the Unity forums where you can talk everything visual scripting and also hear updates about the feature directly and pretty frequently from the visual scripting team themselves. And lastly, this link below is a list of projects that you can download and reference for visual scripting, including the demo that I'm showing here today. And there's also videos linked in that GitHub repo that you can use to watch a full kind of overview of how to use visual scripting. But that's it for me. So I'm going to go ahead and pass things over back to Ben.
Hey, my thing going here. Thanks, Ashley. That's great. I know I've played a little bit with visual scripting so far, and it's really exciting, even as a programmer, to be able to add artists and other people into what I do is really awesome. So up next, Andy. Andy, you ready to go?
I think so, yes.
All right, let's see.
Groovy. I'll just set everything up. Well, I have it set up. I just need to start sharing my screen. And like this. And oh, that's jumping a little bit ahead, spoilering what I'm about to show you. So I guess everyone can see my screen okay? I mean, I hope so. Excellent. So now onto the 2D section. So, or as I like to call 2D or not 2D, which is a terrible joke that I've been living with for almost 10 years. So I'm covering the 2D features and improvements, both in 2020 LTS, which you can see in the column on the left, and the tech stream, which is 2021.1. These are just a few of the improvements. I'm not going to go over all of them because this webinar will probably go on for an extra 2 hours and people have places to go and things to do. But as you can see in a lot of these updates and a lot of these improvements, a lot of them are building on top of the foundation 2D already has. So for example, here on the left, you have 2D animation, which has been in Unity for a number of years, but now adding burst compatibility with the burst package for much faster performance. Things like Sprite Shape Bake Mesh. You know, Sprite Shape has been in Unity for a long, long time, but this is adding extra sort of improvements onto what is already there. So a lot of this part, this tech stream with 2D is taking what we have and then improving it and adding new workflows and things to help you to make 2D games. There's a couple of areas that I'm going to specifically focus on. One is sprites and rigging. So I'll cover through the improved Sprite Library and Sprite Swap workflows, which is useful for things like animated characters, rigs, and things like that. Graphics and rendering, I'll cover the new 2D renderer camera sorting layer texture. That's quite a mouthful to say, but it's basically a sort of system like GrabPass where you can capture the 2D frame and then access it in shader graph from custom shaders for overlay effects. So as you can see here, we've got the normal render, then in the middle like a black and white filter, and then like a posterize effect. And you can do all sorts of interesting UV and color manipulation. And the last thing I'm going to cover, which is a bit different, is world building. And in this, I'm going to cover isometric tarmap slicing. So if you're making games like this, where you have isometric tiles that build up a angular isometric perspective grid, this is a new slicing method to allow you to bring your assets in and prepare them in a much faster and quicker way than before. So even though Unity has had, Sprite Library, a 2D renderer and isometric tarmaps or tarmaps for a number of years. These are all just new improvements that are being added with 2021.1. So I'm now going to switch over into Unity and let's show this. So this is a new example project that we built and released recently on 2020 LTS. It's Dragon Crashers and it's a idle RPG mobile focused game. So we have these characters and they attack the dragon. Obviously the dragon attacks back. They have automatic attacks, VFX. We've got lots of really pretty things. As well as focusing on animation, we also focused on areas such as graphics, such as lighting, particles, UI, a little bit of everything. You can download this project right now from the asset store. And I assume someone from the 2D team will share the link into the chat as I say this. Or they'll do it in a couple of minutes, it's okay. So in the scene, if I switch over to the scene view, what I've done is I've taken this project, which was on 2020, and I've upgraded it to 2021.1 just to show you these new improvements and how they can transform and take this project a step further. And we do this a lot internally with our projects to show how the new features work, how they improve projects that we're already working on, already released. And so you can sort of see the before and after and the delta of this, where the performance gains, where the workflow gains and things like that. So the first one that I'm going to focus on, and my computer just froze a little bit. First one we're going to focus on is Sprites and Rigging, and that is Sprite Library. So a Sprite Library, which I can create from this little assets create window, is basically a collection of sprites that you can filter into categories and labels. So if you have, say, 20 rocks of different types, you can put them into a sprite library and then assign them to a sprite and interchange them. If I select this rock here, this is actually using this exact sprite library. So you can see on the right here, we've got a list of all these different sprites of different types of rocks, which have been loaded in. And I can actually choose what sort of type of rock I wanted this particular, formation, and obviously reposition it. And of course, you can set up different categories, such as like medium rock here. We've got a lot of rocks in this project, stalactites hanging from the ceiling. And it's basically a way of gathering and grouping a set of sprites together and being able to interchange them. You can do this with a variety of different libraries. So I could choose like a crate and then place a crate like so, or like this minecart. And it's actually a workflow that allows you to very quickly sort of author and sort of put together different formats. So it's great if you have a lot of one type of asset and then you want to quickly composite them into the scene. I've noticed in chat some people are saying that the screen is a bit blurry, so I've turned on the optimized video form. I'm actually going to record, well, I'm currently recording this, so we can share the recording afterwards. It should be a lot clearer to see. So yes, this is the Sprite Library. Now, Sprite Library was actually in Unity 2020. However, Sprite Library was tied very closely with the PSB, PSD workflows. So it generated a Sprite Library asset if you imported your 2D artwork as a PSB form. Now, obviously, a lot of people use Photoshop to create PSDs. However, a lot of people use other tools like Affinity Designer, Microsoft Paint. There's plenty of 2D tools out there that people use to create their artwork. So what the 2D team have done is they've actually changed Sprite Library to not be tied directly to a PSD or a PSB asset, but instead you can now create it separately. Like as I just showed you, you can create a new Sprite Library asset here and set it up using sort of any sprites that you have in the project. So this way it's a lot more flexible with other workflows. So if you use Unity 2020, you'll already have this with PSBs, but now this is open for everything. So swapping between these different sprites, these are all actual separate meshes, which are then atlased on runtime. And you can have a lot of fun in sort of compositing your scene. Now, Sprite libraries also allow you to set up sprite swapping using these resolvers for things like characters. So here I have this witch character and she's fully rigged. So she's got a biped rig. She's got IK on her hand. She's got a little nested prefab staff as well, which has lighting affecting everything. So in this demo, we've tried to tie in a lot of different systems together, from lighting to rigging to IK to render layers, Sprite LS, a little bit of everything. I think this uses like 95% of all 2D tools that Unity actually ships. And the ones we didn't use just didn't make sense to add into this project. So what you can see here is that she uses this sprite rig, and she's got this IK for a hand. Now, we have a lot of humanoid bipeds in this project. We've got this witch, and we've got this knight, and we've got this wolfman. So obviously what we want to do is we want to author animations and rigs and have them work seamlessly across all these different characters. Now, using that sprite library setup, you can set up sections for different parts of the biped character. So if I select the character, let's go to the roots. I've already got this sprite library of this witch with head, the hair, the eyes, all the different body parts that's set up here. And then set up a separate sprite library for each of the individual characters. And it means that once we have a animation playing, so let's go with the witch, which is idle. So she's now idling. This animation is authored entirely in Unity using the IK that's built into Unity now for 2D. I can actually switch the sprite library for other types of characters. So I can actually open this up and I can go, now choose the wolfman. Notice that the staff is still in his hand. Now choose the skeleton, because we've got some skeletons that we can fight. Now choose the knight. So we can actually use and share all the animations between all the characters because they're using the sprite library. And each limb is using that sprite resolver to swap between different things, because the knight has a head sprite and the wolfman also has a head sprite. So it's just swapping those things out automatically. It allowed us to build this project using this kind of base biped character, create the animations with this character, and then we knew that they worked for all the other characters in the scene. I just say character quite a few times. So if I go to like this wolfman attack, we can test that this animation works for this, and then we can obviously then pop it out and then see how it looks with the knight, the skeleton, the witch, and the wolfman. It's a very powerful new workflow that allows you to save time on actually building new characters and new setups. And you don't have to make, say, a new idle animation or a new run animation for every character. This also allows us to extend it. So if we wanted to add like a goblin into the project, we can then just base it off of the sprite libraries and then add new goblin. We know all the animations work with it. There's one more thing I want to show you with this sprite swap. And that is if I now select the wolfman, actually, let's move it in his head into a pose. That's a bit normal. I can actually swap between each of these different sprites. So I can have this wolfman, you know, in like angry pose and things like this. So you can actually pop and sort of change different emotions and swap them in and out directly in the scene, but also during the animation. So we have this wolfman's like attack. So he has his mouth open, and then when he swings the staff, he gets into this angry pose. So you can actually keyframe and animate these different sprite resolve swaps. And this carries across to all the other libraries. So if I switch to the witch now, she's also going to automatically, she's going to like, you know, be angry when she's swinging the staff. So everything basically swaps automatically. It's a really nice workflow, and we used it to very quickly create the characters for this project. So yeah, that's basically an overview of the Sprite library workflow. The Sprite libraries are available in 2020 if you import through PSD, PSP, but now as they work with things outside of that format with other types of sprites and PNGs, you can use them for a variety of other things. Cool, so that's assets and sprite rigging. Now, the next section I'm going to jump over to is graphics and rendering. So as you can see here, we've got our scene and it's built up of lots of different parts. We've got some particles at the bottom. We have some flowing, like a flow shader graph in the background. We've got some lava, we've got some lights and things like this. And in Unity's 2D renderer, which is part of the universal render pipeline, we can make use of, say, like dynamic lights. So this is the whole scene without any dynamic lights, and this is all the scene with all the lights enabled. So like normal maps and Fresnel and all these different things are being affected. However, you might want to sort of level up your skills or level up what your effects are by capturing elements of the screen and then compositing effects with them, like overlays. So in sort of like the built-in renderer, this would be like a grab pass, or it's similar to like rendering the scene to like a render texture and then applying effects and overlaying it. You might want to do something like that. So as the 2D renderer is already rendering a series of sorting layers, you can capture this automatically in the 2D renderer. I don't know why the scene just went black, but that's okay. Okay, the scene went black. Let's try reloading it. Okay, let's not try reloading it. Okay, yeah, I just had to click a button. Okay, so what we've got here in the 2D renderer is a new camera sorting layers texture section. You can bound this to a particular layer. What this is going to do is it's actually going to render all the layers up to a certain point, such as this foreground sorting layer, and it's going to capture that into a texture, which you can then use into shader graph. You can also do things like downsampling. So I've already prepared a couple of examples of this. So I'll just turn this on. So here I've got a just a little window of a sprite. So it's basically capturing, you can notice the VFX along the bottom, it's capturing this window of this frame into this sprite here. And it means that we can also do different things like render things like black and white. This is done with shader graph. We can even use the screen position. So this is now like a little black and white window if you want to do any overlay effects. Now, if I actually open up this shader graph and show you what it does. So if you're familiar with shader graph, you can access or set up different properties of different textures. And if you just set up this reference of underscore camera sorting layer texture, it actually captures that render texture that's already being drawn by the game camera. And then you can then access it into the shader graph. So you can just pump it in just like that. So without writing any code or doing really any work, you can already capture this texture. So I've got this example here of this just black and white filter. I've also got another example of like a posterize effect, like almost like a retro. I'm a big fan of retro games. So basically it just captures the that texture and then allows you to sort of like clamp the values to this posterized sort of window. And another example I add, which is good old refraction. Literally everyone makes this when they get access to this type of texture data. So here it just takes the texture and rather than manipulating the colors, it just manipulates the screen UV instead. And obviously I can do things like change the blend distortion. Poor dragon is now in a lot of danger now. So you can capture this camera overlay texture and then add a lot of extra different effects and things to your games. So looking at the scene, I wanted to incorporate this kind of effect into something that actually ties into the scene. Like stuff like this doesn't like really fit the game currently. So what I wanted to do is I wanted to utilize this foreground where we have these sort of like blurry objects and then implement a refraction because they're fighting in like this lava, fire, hot environment. So I took that camera layer texture and I basically applied it to this smoke trail that we had up here, which originally was just a solid color, and then added a little bit of refraction based on the alpha. So just by adding that into the scene, we already have a very sort of, it's a lot more of an impactful effect and it adds a lot more depth into our scene without having to do a lot of extra work. And it's already capturing that camera, it's already getting that texture and we can add this. So it's basically like, you know, the standard refraction everyone makes when they start playing this with 3D, but then it's now in 2D. So we now got this rippling effect here. It's being applied to a line renderer. So it's just shader graph being applied and getting the data from the line renderer here. And then obviously you can do things like set the thickness of the smoke. If we want a more ominous environment, we can do the refraction amount. So this would be like if you wanted to use refraction for like water. Let's do the noise scale. Okay, that's more like water instead. And it's really cool that we're able to sort of like take this data and then manipulate it directly. Like I remember using Flash like 10 years ago, trying to do stuff like this. And it was a huge pain, whereas now it's just too quick. And I say this all the time, I wish I had a time machine and I could just take these tools back into the past and give them to my former self, save a lot of headaches. So yeah, that's one scenario using this camera sorting layer texture. I'm really curious what other people are gonna make with it. You can do outlines around things, you do all sorts of really cool stuff. So the next thing I'm gonna talk about is isometric tarmaps. So I'm gonna jump over to this project here, something a little bit different. So isometric tarmaps are nothing new in Unity. They've actually been in for quite a long time. And I've just painted this little island set up like so, using assets from Srp Packages, I guess. And he's made this amazing asset store pack, which I'm using for this demo. So isometric tarmaps are nothing new. They've been in Unity for a while. However, the workflow of actually preparing the tiles beforehand was a little bit cumbersome because you've got this kind of strange angular tile that's not quite square and it's not quite, you know, like hexagonal. It's like a strange perspective. And also isometric can come in all sorts of different forms. You can have kind of like more top down or more angled in this form. So what the 2D team have done is they've added new slicing workflows that allow you to make this a lot easier to import in isometric tarmaps, specifically flat isometric tarmaps into your games. So if I go into the sprite editor, I've got here prepared a pretty much standard path tile with different rows and edges, something that you'd probably paint on top of a surface. And if I go through the different slicing methods of the slicing types, I can show you kind of the reasons why you wouldn't use these other ones, but why you would want to use the isometric grid. So let's try automatic. Everyone has clicked this button at some point with Unity 2D. So it's basically trying to detect where these automatic pieces are that are individual on this grid. So it's actually worked kind of nicely for this. I mean, there's 2 tiles here and it's come out as one slice. So it's, I guess, halfway there. This is not working. I mean, this is one big mess. You know, like this tarmap wasn't created for this automatic slice type. Now let's try grid by cell size. So I know each tile, because I prepared this, is 256 by 128. So that seems pretty good. But what you can notice here with this preview overlay is it's going to slice these tiles, but then it's going to keep some of the bleeding over edges, such as this area here and this area here. And this also kind of like not really chops the center of this tile, like it's going to chop this one into 4 pieces, which is not really what we want. And instead, I'm now going to go to this grid by cell count. And what you'll notice here with grid by cell count is we've got the 10 rows and the 10 columns. However, that's not really working. It's not really slicing as intended. So what I'm going to do now is I'm actually going to switch over to isometric grid. And what isometric grid does, let me go back to it, is it allows to type in a size of each individual tile, and it'll actually alternate the slices along. So it'll work out where each tile is and alternate them throughout the process. So if I now slice this, let's see the results. So this one has worked, this one has worked. We've got this one, we've got this one, we've even got this one. It's done a couple of extra ones, but we can obviously, like any good automatic slicing tools, we can tidy this little bit up. But you notice here, especially in this part, that basically it's managed to calculate a slice here and a slice here. So we're going to get each of those individual tiles. The other thing that it'll do is it'll actually cut out any overlaps that we'll have. And you can see this when I actually hit apply. So now if I go back to my tile interface and go through my tiles, it's automatically sliced out any sort of overbleeding edges that might be next to another piece. So remember with this corner tile, there's like some extra pixel data here. Instead, it's, okay, we've got a couple of blanks, but that's okay. It's actually sliced pretty much all the slices out for me. Now with these tiles sliced automatically, I can drag them into the Tarmac palette. Let's just save this into the tiles into here. That's fine by me. It's now going to create tiles automatically from those individual sprites. I would say go make a cup of tea, but it's too fast. You won't have time to boil the kettle. And then what we've got here is we've automatically got our Tarmap, which looked identical to the source asset. And we can now go in and just be like, oh, let's paint, you know, a couple of individual parts here. Let's paint like a whole section here. Let's paint a road. And that's great. Now, obviously, this is very time consuming if I was going to go into each individual like tile and place them. So that's why we have this rule tile, which I will actually show you what this looks like. It's going to look a little intimidating. I'm just warning you now. So you basically load in each of these individual tiles and you set up the rules. So set up where their edges are and where they continue onto other parts of this path. So a dead end will obviously have one green arrow going out, whereas red crosses for the sections where there's no continuation of the path. It's a little bit time consuming setup, but once you've got it all already done, which I've already got here, you can then paint paths all day. I could do this for an extra, yeah, I could super quickly, I can paint. It's automatically going to work out all the neighboring tiles. This rule tile is nothing new, but I'm just showing that this works with the sprites that have been sliced with this isometric workflow. So it's basically taking workflows you already have, but then making them a lot nicer and a lot easier to prepare your assets for. I can now switch to details. This is my Bob Ross moment where I now start painting some nice trees onto the tarmap, paint some nice flowers as well. All it needs is a character or a car or something to drive around. Very quickly, you can world build and set up your level. So you can slice up your isometric tiles, build up something that looks visually pleasing using these Tarmap tools. And with that, I'm going to pass back to Ben, I think it is. So, before that, I'll just wrap up. So we've got Sprites and Rigging using this new improved Sprite Library workflow and Sprite Swap. We got this new 2D renderer camera sorting layer texture for overlay effects. We also have this new isometric tarmap slicing method, which makes it far easier to import in isometric tarmaps directly into Unity. I'm now going to pass it back to Ben.
Thank you so much, Andy. Let me take the screen share here. Once again, so that was just a few of the features that are available in the latest Unity 2021 tech stream. There's a whole bunch of them. If you do want to check out more of those, we have some links here for you that I will also put in the chat right now. They'll be there in just a second. Thank you so much for tuning in today. We had a few questions come in. If anyone else does have any questions they want to ask us at this point, now's the time to do so before we sign off. I know we're a few minutes over time, but that's all right. If you do want to check out any of those features, we have the Unity 2021.1 beta webinar. It goes over the features we covered today, plus a whole bunch more in detail. You can check out that link there on YouTube. We have the 2021 release notes. If you want to read the updates, bug fixes, all the kind of stuff that went into Unity 2021.1, the link is there as well. And if you're still debating if you want to use the tech stream or the LTS version, we have an overview of the releases as well that might be able to help you get a better understanding and make that decision of which one to use. So let's see if we have any questions here. Right now, we're looking pretty good. Did anyone else, presenters or R&D team, want to add anything before we sign off as well? Silence is golden. I do see a question here. We'll see if anyone has an answer to this. Regarding UI Builder, etc., is there any plan to be compliant with HTML, CSS? I don't know that answer myself. Does anyone else have a confirmed answer on that? Again, silence. All right, we're not sure on that one. I haven't dealt with that myself, and I don't want to give bad information by confirming or denying that right now. But I will see if we can get you an answer for that and reach out to the team.
I haven't used UI Builder recently, so don't quote me this, but now people are going to quote me on this, so that's great. So I think it's aiming to be HTML and CSS like, but not directly HTML and CSS. So it's going to have some similar structure and foundation and things. So there's going to be a lot of similar terminology, like align here and pad this box and things. So if you come from that web development background, it's basically going to be like similar type of language. Similar type of mental language as opposed to exact language. Although it'd be worth getting a more concrete answer from the team and then responding on, say, the forums or somewhere. Yeah. At least that was my experience with UI Builder and things like this, because, yeah.
All right, thank you. Yeah, and if you do have questions that we can't answer today, a reminder, the Unity forums are a great spot to ask those questions. A lot of members of the community are there, as well as the developers themselves. So if there is something we can't answer right now, the forums is another great spot to go. I use it all the time. Looks like our questions are pretty slow and at a standstill, and I know we are over time. So maybe this is a good time to sign off for the day. Thank you everyone so much that did tune in today. Hopefully we were able to give you some overview of the new features. Hopefully you saw some stuff that was useful. I know before Andy even covered the tile map, people were talking about isometric tile maps, and I was like sitting here like, oh, just you wait, I know it's coming. So I'm really glad we could do that. So thank you everyone so much for tuning in. Was there anything else anyone wanted to add from the presenting team? All right, silence is golden. Then I think we'll end it there today. Thank you so much on behalf of myself and everyone here at Unity for tuning in. Hopefully you'll find these features useful, and I can't wait to see what you guys make in your own games with this. So have a good day, everyone. Goodbye until next time. Catch you soon.
Cheers, everyone.
Bye.
Bye.
Thanks everyone.
Ciao.